Okay, guys, so we are going to get introduced to the wonderful world of probability. This section's kind of unlike the other sections. It's kind of an oddball section, okay? All of a sudden, they just drop probability and simulation into your lap. And we're going to do a lot of things with simulation and probability, but we're just going to get started with it here, okay? We'll probably do some activities from Stats Medic. I think their stuff's great, so I'm sure we'll do some of those too. We'll get started. I got a couple special guests with me today. I don't know how long this will last. I've got the two fellas here today. I've got Oscar and Rio. Let me see if they'll come over for me. Can I step up? Step up. So this here is Rio, okay? And he didn't go to the bathroom on the paper, so that's a good sign, right, buddy? Now let's see if I can get Oscar over here. Come here, buddy. Step up. You're okay. You're okay. This guy gets scared. It's okay. It's okay. It's okay, buddy. Okay, see? You're all right. You're all right. I'm going to put him back on his stand. So they're on their stand here. They're kind of keeping an eye. I'll see. You can hear Rio talking. Rio, step. Rio, step. Sometimes you'll hear him just start talking. The other guy will probably start squawking. But a couple special guests today. So we have a random process is unpredictable in the short run, but has a regular and predictive pattern in the long run. Okay, this is the basis of probability. The most basic probability that I know of is flipping a coin. Okay, and it's unpredictable in the short run. That's why before games, athletic contests, or to settle things, you flip a coin. Okay, it's a chance process. You have a 50% chance of getting heads and a 50% chance of getting tails. Now that doesn't mean that you can't get 8 heads in a row. One thing does not depend on the next. Each flip of the coin is independent of each other. Okay, and in the short term, it's very unpredictable. But if you do it over and over and over again, you'll see that probability gets closer and closer to 0.5. You could flip a coin 100 times and you might get 40 and 60, okay? But the more you do it 500 times, you do it 1,000 times, you do it 10,000 times, you get closer and closer to the true probability, which is 0.5. So a random process generates outcomes that are determined purely by chance. So these are the things about probability. So it says probability of a chance process is a number between 0 and 1. You can't have a negative probability. Okay, 0 is something that can never happen. Okay, someone jumping over a building. Okay, that can never happen. Okay, something that's certain to happen. The sun coming up in the morning. Now I don't mean coming out, but each day the sun comes up. There's a probability of 1 that happens. That doesn't happen, we're in big trouble. Okay, and everything else is in the middle. Everything else is between. Okay, when you're talking about rolling a die, getting a 5, that's 1 out of 6. That's a probability. Flipping a coin, 1 out of 2. That's a probability. Okay, and there's lots of other things that we'll talk about. The fact that the proportion of heads in many tosses eventually closes in on 0.5 is guaranteed by what's called the law of large numbers. And that means that the more times that you do it, it'll get closer and closer to whatever that true probability is, even though in the short term, things can be very unpredictable, okay? The myth of the law of averages, some people say, you flip a coin 6 times and you get heads on all 6. And they'll say, well, it's got to come up tails next, okay? Just because of the law of averages. That's a myth, okay? There's nothing, every flip is independent of each other. You could get heads 10 times in a row. Then you could go get tails 10 times in a row. Okay? So there's no one flip that's more likely than the other, even when you get 4 heads in a row. Okay? There's no greater power that is making that coin flip to 2 tails in that situation. Now, here is somewhere where I disagree with the people in the world of probability. And that's where it says the shooter seems hot. They don't believe in that, okay? They do not believe in that. They think that someone that's shooting a basketball or a free throw or whatever is just a chance process. And there's not any days that they're more likely to make more than they are to miss. Now, I've been around sports a long time. And I think, and I know from when I play, that there are certain times when you shoot and you just know it's going in, okay? And you just, on those days, I think you have a better percentage. But the people in the probability world say that's just a small window and anything can happen inside of a small window, okay? But I tend to disagree. I think that there is a higher percentage to making a shot on a day when it's your day or when you're hitting your shots. I just believe in that. So the probability world does not. So it says, suppose that a basketball announcer suggests that a certain player is streaky. That is, the announcer believes that if the player makes a shot, he's more likely to make his next shot. As evidence, he points to a recent game where the player took 30 shots and had a streak of 7 made shots in a row. Is this evidence of streakiness, or could it have happened simply by chance? Assuming this player makes 50% of his shots and the results of a shot don't depend on previous shots, how likely is it for the player to have a streak of 7 or more made shots in a row? So using a coin, let heads represent a made shot and tails represent a missed shot. So when we get to this point, I don't know if you guys are going to be with me or remote or what. So I don't know if we're going to carry this out. So we're just going to talk about it today. Flip a coin 30 times and write the outcome after each flip. So I hope that we do this. I do hope that we do this. I hope I'm able, we're able to pull this off and see what happens so you guys can get a better understanding of probability. Writing down the outcome after each flip. Record the length of the longest streak of made shots. Repeat many times and combine your results with your classmates. In what proportion of the trials did the player have a streak of at least 7 in a row? What's up, Rio? So they did this 50 times. Okay, and here are the 50 trials. Each time you do it, it's called a trial. So the player had a streak of 7 or more made shots in 7 of the 50 simulated games. So that's a simulation. When you have a simulation, and sometimes it's not easy to pull off a simulation because of, like right now basketball. Where are we going to shoot a basketball? I guess you could do it in the gym, but who knows? You have to do it with a mask on and all the other crap that's going on. So they have a simulation to, I'm trying to think of another word than simulate, but so you can simulate the chance process, okay? And so they were doing it by flipping a coin because they were assuming that the person was a 50% free throw shooter. Okay? Here's another one. The graphs below show the short run and long run behavior of the proportion of trials in which there are no matches when 4 students choose a book at random. The blue line is the correct probability of 0.375. As you can see, in the first 20 trials, there's a bit of variability. However, after 500 trials, the proportion of times is quite close to the actual value. So this is an example of the law of large numbers. So I think you have, there's like 4 books, and let's see what it is. No, I don't know what it is because it says the probability is 0.375. But this is what happens in the short term. 1 trial, 2 trials, 3 trials, 4 trials. You can have some variability there. But if you look over here, once you get to like 500 trials, the probability almost gets to be a straight line, right on what that true probability is. So this is what happens in the short term. This is what happens in the long run. And that's why they have this law of large numbers. Okay? I got this guy's panicked. Let me see. You want to come here? These guys are nervous. I don't know if it's the tripod or what. They could be nervous about the tripod. Because there's snacks here, guys. See if I can get them to eat a snack. Maybe I'll get them to loosen up a little bit. Here you go. You want it? That guy's trying to bite my finger. Nice guy. Here I am trying to give him a snack and he's going to bite my finger. The other guy wants to lick my finger. All right. So, Joe DiMaggio's hit streak. This is one of the most famous streaks in professional sports. Okay, this guy named Joe DiMaggio. I believe it was the same year that a guy in the Red Sox hit 400, and he's the last person to hit 400. 400 means that over the course of the season, okay, he had a 400 batting average, which means he got a hit 2 times for every 5 times he came to the plate. A good batting average in the major leagues is about 300. So 400 is extraordinary, and to do it over a course of a season, it hasn't been done since the 1940s. I want to say it's 1942, but I'm not certain of that date. So I think it was in that same year. Now, the guy who hit 400 was in the Red Sox, okay? His name was Ted Williams. Okay, and the same year, there was a guy in the Yankees. Okay, the Yankees had a much better team back then than the Red Sox. They had a lot of good players. The Red Sox only had a few. This guy named Joe DiMaggio. Okay, there's 2 things that he's famous for. He's famous for being a fantastic baseball player. Okay, but he's also famous for marrying one of the most famous people in entertainment history. He married Marilyn Monroe. Now that, I don't even know if you guys know that name, but back then she was a real big deal, and she was married to a guy in the Yankees. There's also other stories about this woman here who said that she had an affair with a president who was JFK, so I don't know, but I know she was married to that guy. So in the same year that Ted Williams had this fantastic statistical season, Joe DiMaggio had an unbelievable streak, and what he did was he got base hits in 56 straight games. Well, you know, if you have a chance of good players every 3 out of every 10 times getting a hit, and you expand that, you probably get 3 or 4 at bats a game, and you expand that over an entire season, and he got a hit in 56 games in a row. And that's just an unbelievable feat, okay? And it hasn't been even come close to yet in recent years. Someone gets like in a 25-game hit streak, and that leads SportsCenter. So it says, one of the most remarkable streaks in baseball history, Joe DiMaggio's 56 consecutive hit streak, was not very remarkable at all. Now, here again, I disagree with the statistical people. Obviously, it's extremely unlikely for any particular individual to have a hitting streak this long. But when considering all the players in all the seasons in baseball history, we should expect some very unusual performances every now and then. To investigate, they simulated the performances of every baseball player in every season a total of 10,000 times. In each of those 10,000 simulations, they recorded the longest hitting streak. And they said 42% of those trials in that simulation had a hit streak of at least 56 games. And they did it another time, 109 games. Well, I think that this might make sense for in the statistical world with numbers, but baseball isn't always played by numbers. Sports isn't played by numbers. Real life events aren't played by numbers. They're played by human beings. And so I still think that this is just a crazy accomplishment, and it's not something that's been approached since. But the laws of statistics, when you look at the numbers, people will tell you it's not that big of a deal. Okay? I'm hopeful that at the end of the year we have time to watch. There's 2 movies that we watched at the end of the year. Now, we didn't watch them last year because of the situation, but Moneyball, and there was another one with John Travolta. I just can't think of that one right now. But it has statistics in it, especially this one. We always watch that in the spring after the exam. So I'm hoping that we can, and we can talk about how sports and statistics are so closely related. Okay? So this one here talks about red is due. In casinos, there's often a large display next to every roulette wheel or roulette table showing the outcomes of the last several spins of the wheel. Since the results of previous spins reveal nothing about the results of future spins, why do the casinos pay for these displays? Well, the reason is many players use the previous results to determine what bets to make, even though the math tells you that it's not going to help them win. And as long as the players keep making bets, the casino is going to keep making money. So, it's one of those things. The math behind it doesn't make any sense. Okay, the math behind it doesn't make any sense. But, people still are attracted to that. So now we have this idea of simulation, okay? And this first one, we're gonna go through the simulation. I don't know that we're gonna go through and get the answer to the question, but I want to use the first one as a way to set it up and so you guys can understand how things get set up. So here is that 4-step process again that we've talked about a few times. The simulation says it imitates a random process in such a way that the simulated outcomes are consistent with the real world outcomes. So that's what we're going to do. We're going to perform a simulation because we can't do this. We can't do this problem. And I'll explain why. So state, remember, it's like restate. What are they asking? Plan, describe how you're going to use the process. Do, perform many repetitions. And conclude, look at your results and answer the question. Now, instead of saying a probability is 18 over 100, it's better to say approximately 18 over 100. So I'm going to pause this right now because the two fellas here, one is happy eating snacks, the other guy's petrified. So I'm going to probably move them, come back, and we're going to look at this one with the cereal boxes with David Ortiz, Tom Brady, and Serena Williams.